Hello, everyone. This is your video answering that age-old question, what is a radian? Well, there are two ways that we have to measure an angle. One of them you are already very familiar with, and that is we can measure an angle in degrees. And we know that a circle is 360 degrees. So that is one way that we could measure an angle. The second way that we could measure an angle is in this unit called a radian. And here, each circle is 2 pi radians, which I know just seems weird as can be. And why would we ever want to do that? I know. I get it. I feel for you. I am sorry that you have to learn this new thing, but you do. So let's talk for a second about the abbreviations. The abbreviation for degrees is that little degree sign, right? So it would be X degrees that an angle could be. Radians, the abbreviation for radians could be a capital R, but lots of times it's nothing. They just put the number there and that's it. So the rule is that if there is no degree sign, you should assume radians. If there is no degree sign, you should assume radians. Also, another big hint, if you see pi, you're probably in radians. That's your other big hint. Radians are actually a more popular way to measure angles. And it's popular because I don't know why. To me, degrees is so much easier because I've been using degrees for so long. And the same with you. I mean, you years under your belt, you've been using degrees now. So switching to radians will seem kind of weird at first. Well, and maybe even at second, but eventually you will perhaps come to appreciate the radian. Let's draw a picture. So here's a graph, and I'm going to draw a circle on my graph, and I'm going to try to do a pretty good job. I give it an okay. All right. So let's say that we were to start right here at 0 degrees, and we were to go around the circle. So we were to go to here, this would be a 90-degree angle. If I were to stop right there, that angle would be 90 degrees. If I were to keep going, I would get to 180 degrees. If I were to go even farther, I'd get to 270 degrees. And then if I completed the entire length around the circle, that would be 360 degrees. Okay, so far, so good. Let's take a look at what that looks like in terms of radians. So this is 0 radians still, but we know that if we go all the way around the circle, that is 2 pi radians. 2 pi radians. That's how far it is all the way around the circle. Halfway around the circle would be half of that. And what's half of 2 pi? Well, that would be just pi. So this is pi radians to go halfway around. And then if I were to take that 1 pi and I were to cut it in half again, that would be pi over 2, or 0.5 radians, 0.5 pi radians, excuse me. And then if we were to draw another line right here, let's say right there, so that that would be 45 degrees. In radians, what would that be? Well, That would be pi over 2 divided in half again, which is pi over 4 radians. And then if we were to make yet another angle like this, and we were to call that 30 degrees, so that's a 30-degree angle right here. What is that in radians? Well, if you 30 is 1/6 of 180, right? If we were comparing degrees, 1/6. And so if we were comparing in radians, it would be 1/6 pi, or pi over 6. So you can see how you can easily ish move between certain degrees and the radians. What do you have to remember? You have to remember that one circle is 2 pi radians. Now you might be asking yourself, why, why, why did mathematicians invent this? I mean, okay, it's there. I understand. I have to learn it. It's probably going to be on the test. But why did they do it? And here is why. So mathematicians like patterns. They like it when the world makes sense. And if you recall the formula for circumference, CD pi, ICD pi, right? C equals the diameter times pi. This is a known formula, and we've been working with this formula for years and years, right? What's another way to write diameter? Well, that would be 2 radiuses pi. So I could write C equals 2r pi, right? And usually, this is the way people say it. The circumference is 2 pi r, right? 2 pi r is the formula for your circumference. And you will notice that 2 pi right here, that is radians. Radians in a circle times the length of the radius. And that makes up your whole circumference. Now, you might not like this, but mathematicians like this. They're like, ooh, look at that. We're like making 2 completely different formulas kind of connected somehow. So that's how radians got to be the way radians are. Here's the important thing. On your calculator, you have different buttons. Even if you do not have a calculator exactly like mine, when you turn your calculator on, you should see little somewhere the letters DEG, or sometimes it's just a D inside of a box. That's another very common way for calculators to do it. That means that you are working in degrees. If I hit this button right here, DRG, I can switch between degrees and radians, and then I just have to hit enter. And so now you'll see that I am in radians instead of degrees. And for those of you who are curious, there's also this thing called a gradient, which is yet another way to measure angles, but we're not going to talk about that. We're going to talk about radians. And it is very important that your calculator be set properly. You have to know whether you are working in degrees and radians. And let me just show you. Let's say that we were going to do the cosine of 49 degrees, and we were in degrees. So cosine, oops, I have to get back into degrees. Hold on a minute. Okay, there we go. Cosine of 49 in degrees is going to give you 0.656, right? But if you do cosine 49 in radians. I'm going to switch to radians now. And I'm going to do cosine of 49. I get 0.301. So you see that there is a big difference in your answers here. So sometimes if you're doing your homework, if you're trying to check your answers and your answers are just wildly inappropriate, I bet it would not be a waste of your time to check to make sure that you are in the proper mode, in the proper unit for calculating what it is you're trying to do. So make sure that you pay attention and you know what's happening there with your degrees versus your radians. Okay, good luck.